Can you solve this difficult physics problem? A ball is launched horizontally off a 45-meter cliff and lands 60 meters horizontally. It then enters a loop, and when it reaches the top of the loop, it will have some normal force. We need to find what that normal force is given the variables that we know. We first need to solve for this v naught that this ball is launched from. To do this, we'll have to use our kinematic equations. So let's start with the y direction. In the y direction, we know that the change in y equals the v naught in the y direction times time, plus 1/2 the acceleration, which in the y direction is just gravity, times time squared. But since this ball is launched horizontally, there will be no initial velocity in the y direction, so we just get that the change in y equals the 1/2 gravity t squared. And so we can rearrange this equation for time and get that time equals 2 change in y over g, and then everything under a square root. Now we can go ahead and relate this to the x direction. Since there's only horizontal velocity initially, and the x direction's acceleration will be 0 since we're assuming no air resistance, the velocity will equal the change in distance over time. And we're given this change in x, so we can get that the velocity equals the change in x over everything we just calculated for the time. Now we can go ahead and plug in the variables we were given, and we see that the velocity is 19.8 meters per second.